So I know a lot of people struggle with functions, and this exam question here is the most amount of marks that have been available for a single exam question involving functions. There are 13 marks available here. This is question 10 in one of these specimen papers. I think this is a really good question. I think it incorporates a lot of different skills to do with functions. So if you want to have a go at it first, pause the video, have a go, and I'll go through the answer now. Okay, so for this question, we're told the function f is defined by this here, where we can say that f of x is equal to 3x minus 5 over x plus 1. And for part A, we need to find the inverse function of f of x for 3 marks. Okay, so we did a video on inverse functions. The way that you find an inverse function is, so if f of x is equal to 3x minus 5 over x plus 1, we're going to rewrite this. We're going to say that y is equal to this 3x minus 5 over x plus 1. And what we're going to do is we're going to rearrange this to make x the subject instead. Okay, so to do this, so we have this x plus 1 denominator, so to get rid of this, let's multiply both sides by x plus 1. So on this side it will be y multiplied by x plus 1, and this is now equal to the numerator, which is 3x minus 5. And then if we expand this bracket here, it's going to be xy plus y is equal to 3x minus 5, like this here. Now we're trying to make x the subject, so let's get all of the x terms onto one side of the equation and all of the non-x terms onto the other side of the equation. So let's get all of the non-x terms onto this side of the equation. So this y will still be here, and then let's move this minus 5 onto this side, so it will now be plus 5, and then this is going to be equal to, and we got all the x terms onto this side, so we're still going to have this 3x here, and we're going to move this xy onto this side, so now it's minus xy, like this here. And then what we're going to do, we're going to say that y plus 5 is equal to, then let's factorize x out of this, so it's going to be x 3 minus y, like this here, and then divide both sides by 3 minus y, so we get that y plus 5 over 3 minus y is equal to x. And then what we're going to do is going to switch around the x and the y terms, so therefore this is going to be y is equal to x plus 5 over 3 minus x, and this here is the inverse function. F minus 1 of x is equal to x plus 5 over 3 minus x, and this here is the inverse function. Okay, and then for part B, we need to show that f of x is equal to x plus a over x minus 1, where a is an integer to be found for 4 marks. Okay, so this is a composite function question. So remember, in order to find f of x, so we know that f of x is equal to 3x minus 5 over x plus 1. In order to find f of x, what we essentially need to do is we need to sub f of x into f of x. So what I mean by that is we're going to write out this 3x minus 5 over x plus 1. So it's going to be 3, but then instead of this x term here, we're going to sub it out for this 3x minus 5 over x plus 1. So it's going to be 3, and then 3x minus 5 over x plus 1. And then we have this minus 5 on the end here, and this is over x plus 1, but instead of x here, we're going to sub it out for this 3x minus 5 over x plus 1, like this here, and then we still have this plus 1 on the end here. And we need to show that this here can be written in this format, so we need to do some simplifying. So firstly, we have this 3 multiplied by this fraction here. So if we expand this, it's going to be 3 multiplied by this numerator here. So 3 times 3x is going to be 9x. Then 3 times minus 5 is going to be minus 15. This is over x plus 1, and then minus 5, and this is over 3x minus 5 over x plus 1 plus 1, like this here. Now here we have these fractions inside a fraction, which is a bit difficult to work with, and the best way to deal with this is in the numerator we have two terms, and in the denominator we have two terms. What we're going to do for both the numerator and the denominator, we're going to combine these terms into one fraction. The way that we can combine fractions, remember, is if the denominators are the same, and the denominator here is x plus 1 and the denominator here is x plus 1. So for 5 and 1 here, we need to make the denominators x plus 1. So the way that we're going to do this, so this is equal to 9x minus 15 over x plus 1, and then this is minus 5, but this 5 here, we're going to multiply this by x plus 1 over x plus 1, so this will become 5 times x plus 1 over x plus 1 like this here. And now we can combine these fractions because both of the denominators are x plus 1, and then this is over 3x minus 5 over x plus 1, and then this is plus 1, but again we're going to multiply this 1 here by x plus 1 over x plus 1, so this is just going to be x plus 1 over x plus 1 like this here. And again, the denominators are the same, so we can combine these fractions. So this is going to be equal to, so in the numerator it's going to be 9x minus 15, and now we can combine this with this numerator here because the denominators are both x plus 1. Let's also quickly expand this bracket here. So we have minus 5 times x, which is going to be minus 5x, and then minus 5 times 1, which is going to be minus 5, and all of this is over x plus 1, and then this is over, so it's going to be 3x minus 5, and we can combine this with the other fractions, so it's going to be plus x plus 1 like this here, and all of this is over x plus 1. Okay, so we can simplify this, so this is going to be equal to, so in this numerator here we have 9x minus 5x, which is equal to 4x, and then we have minus 15 minus 5, which is equal to minus 20, and this is over x plus 1, and then this is over, and here we have this 3x plus x, which is equal to 4x, and then we have minus 5 plus 1, which is equal to minus 4, and this is over x plus 1 like this here. Now we here have this fraction divided by this fraction, so what we can do, we can rewrite this here as 4x minus 20 over x plus 1 divided by 4x minus 4 over x plus 1. It's this fraction divided by this fraction. Remember, when you divide two fractions, you can multiply them together if you flip this fraction here. So we can rewrite this as 4x minus 20 over x plus 1 multiplied by, and then we flip this fraction, so it's now x plus 1 over 4x minus 4. And what we can do with this x plus 1 cancels out with this x plus 1 to leave us with 4x minus 20 over 4x minus 4. Now we need to write this in this format here, where in the denominator is x minus 1 and in the numerator is x plus a. Now the issue that we have here is in front of both of the x's, the coefficients, we have 4 here. We don't want coefficients in front of the x. So what we're going to do for both the numerator and the denominator, we're going to factorize out 4. So in the numerator it's going to be 4, and then it's going to be x, and then 20 divided by 4 is 5, so this is going to be minus 5, and this is over 4, and then if you factorize out 4 from 4x minus 4, it's going to be x minus 1 like this here, and then this 4 will cancel out with this 4 to leave us with x minus 5 over x minus 1, and this here is in this format where a is equal to minus 5, and this is the final answer. Okay, so for part C, we're introduced to a new function g, and g is defined by g of x is equal to x squared minus 3x, where x is between 0 and 5. And for part C, for 2 marks, we need to find the value of fg of 2. So this is another composite functions question. Now, there are essentially 2 ways that you can do this question. The longer way to do it is you can find the composite function fg of x and then sub in x is equal to 2 in order to find fg of 2. That's the longer way to do it. The quicker way to do it is we're trying to find fg of 2. So firstly, find g of 2, so sub in x is equal to 2 into g of x, and let's say this gives out a value of a. This value of a, just sub this into f of x, so to get f of a, and then whatever value this gives out, let's say it's b, this is going to be the value of fg of 2. Is going to be equal to b. Okay, so what we're first going to do then is, firstly, as we're trying to find fg of 2, let's first find g of 2. So g of x is this here, so it's going to be x squared, so it's going to be 2 squared, and then minus 3x and minus 3 times 2 like this. And if you put this into your calculator, this is equal to minus 2, so therefore we're going to find f of minus 2. So this is going to be equal to 3, and then instead of x it's minus 2, and then minus 5, and this is over x, so minus 2, and then plus 1. If you put this into your calculator, it's equal to 11. So therefore fg of 2 is equal to 11, and this is the final answer. Okay, and then for part D, we need to find the range of g for 3 marks. Okay, so remember g of x is this function here, this x squared minus 3x, and x is between 0 and 5. Now be careful with this question, because what you might be tempted to do is you might say, okay, so x, the smallest value it can have is 0, and the biggest value it can have is 5. So if we find g of 0, so this is going to be 0 squared minus 3 times 0, this is going to be equal to 0, so that's g of 0. And then if we find g of 5, so this is going to be 5 squared minus 3 times 5, which we put into your calculator, is equal to 10. So therefore this is the smallest value, and this is the biggest value, and this is the range. This only works if the function g of x is linear. However, this here is a quadratic. The reason this doesn't potentially work, and this might not be the minimum and this might not be the maximum, is if you think about this quadratic here, this x squared minus 3x, it's going to be a positive parabola. It's possible that it could look something like this here, where this is x is equal to 0 and this is x is equal to 5, and the actual minimum of this function is this turning point here, and we need to consider this, and we need to see if this turning point lies in the range between x is equal to 0 and x is equal to 5. Remember, to find a turning point for a quadratic, the easiest way to do it is to complete the square on this. So this here is x squared minus 3x. Now remember how to complete the square. So what we're going to do, so this is going to be equal to x minus, and then this 3 here, we're going to half this, so it's going to be 3 over 2 like this here, and this whole thing is squared, and then we're going to minus this number here squared. So minus 3 over 2 squared is going to be 9 over 4, so we need to minus 9 over 4 from this here. So this is this quadratic in the completed square format, and therefore if you remember how completing the square works, the turning point is going to be equal to, so the x coordinate is going to be the negative of this value here, so it's going to be minus 3 over 2, so it's going to be 3 over 2, this is the x coordinate, and the y coordinate is going to be this number here, this minus 9 over 4. Now 3 over 2 is 1.5, and 1.5 lies in this interval here between 0 and 5. So this here, this situation is true. This turning point here is where this point is 3 over 2 minus 9 over 4, and this here is the actual minimum point, this minus 9 over 4. So therefore the range of g of x, the smallest value is going to be this turning point here, which is going to be minus 9 over 4. Now as it lies in this interval, it can also be equal to this x value, so we're going to use this inequality sign here. So this is the lowest value of g of x. Now the maximum value of g of x is essentially going to be which of these values here, x is equal to 0 and x is equal to 5, is higher when you sub it into g of x. It's essentially, it could be the other way around, for example, where it could be like this is the higher value, for example. However, we subbed it in, we found that g0 is equal to 0 and g5 is equal to 10 like this here. So this is the case here where this is the maximum point where x is equal to 5 like this here. So the maximum value is 10, and this here is the range of g. It's between minus 9 over 4 and 10. It can also be equal to 10 here because we are told that x can also, with this inequality sign, be equal to 5. So it can also be equal to 10. Okay, and then for part E, we need to explain why the function g does not have an inverse for 1 mark. Okay, so we talked about this in year 2 of chapter 2. We talked about this in the more on functions video. The reason that function g does not have an inverse is if we look at the function g, so g of x is equal to x squared minus 3x. In that video, we talked about different types of mapping, and g of x is something what we call a many to 1 mapping. What this means is that multiple x values can give the same y value. So for example, let's say that x is equal to 1 and x is equal to 2. For this particular function g of x, if you sub in x is equal to 1, so this is going to be g of 1, this is going to be equal to 1 squared minus 3 times 1, which if you put this into your calculator is equal to minus 2. If you sub in x is equal to 2, this is equal to 2 squared minus 3 times 2, which if you put into a calculator is equal to minus 2. So both of these x values, x is equal to 1 and x is equal to 2, give out the same y value. This is a many to 1 mapping. This is fine, but the problem with this is when you convert this into the inverse, it's going to switch around and it's going to become a 1 to many mapping, and this you cannot have. If it's a 1 to many mapping, this is not a function. So the reason function g does not have an inverse is because the inverse is a 1 to many mapping, which is not a function. And that will give you the mark. Just really quickly, if you wanted to wonder why it's a 1 to many mapping, you don't need this for the final answer, is if you try and actually find the inverse of g of x. So remember, the way that you do this is you say that y is equal to x squared minus 3x. If you try and make x the subject here, so the way that we would do this is we would complete the square on this. So we would say that y is equal to, and to complete the square on this, we've already done it, is equal to x minus 3 over 2 squared minus 9 over 4, like this here. Move this minus 9 over 4 onto the other side, so it becomes y plus 9 over 4 is equal to x minus 3 over 2 squared. Square root both sides, so this will be the square root of y plus 9 over 4, but remember this can be the plus or minus square root, and this is equal to x minus 3 over 2, and then move this minus 3 over 2 onto the other side to get the plus or minus the square root of y plus 9 over 4 plus 3 over 2 is equal to x, and then switch the x and y around so it becomes y is equal to plus or minus the square root of x plus 9 over 4 plus 3 over 2. So this is the inverse of g. It's plus or minus the square root of x plus 9 over 4 plus 3 over 2. The reason that this is a 1 to many mapping is because of this plus minus square root here. So for example, let's say you sub in x is equal to 7 over 4. This x value works quite well for what I'm trying to explain. If you sub this into the inverse of g, so it's going to be the inverse of 7 over 4 like this here. So this is going to be plus or minus the square root of 7 over 4 plus 9 over 4 plus 3 over 2. Now this can be equal to two things because this plus minus here. It can be equal to either 7 over 2 or minus a half. This is a 1 to many mapping because one x value gives out multiple y values, and you cannot have this for a function. So the inverse is not a function.